Welcome back, everyone, to the Almadina track. We now have a new speaker, and it's the only speaker that actually spoke at multiple JNations, but never on site in Coimbra. So, Brian, we need you there next year, man.
Yeah, yeah,
I'm really hoping
absolutely.
for that. So we have Brian Vermeer, is a developer advocate at Sneak, Java champion, and jug leader of the Virtual Jug and Netherlands Jug, if I'm not mistaken. Correct me if I'm wrong, Brian. That's a
That
very
is,
long curriculum, man.
you are
He's
absolutely
gonna
correct.
he's gonna be presenting a session on Docker and security. So I really hope next year I can tell you the stage is yours, but for now the stream is yours, Brian. Go ahead.
Th- Thank you so much. And yes, I hope to be back next year in real life to be at the third time. This is my second time. Hope to be the third time. We'll be on site again, and I can see all your lovely faces again because um, doing this virtually is cool, but doing this in real life with real people and having conversations after that, that's the most valuable thing ever. But before I'm going into my presentation, I have to talk to you about this. A container. I mean, what is a container, right? If we think of a container in the real world, a container is something that holds goods or is a receptacle that holds freight or something like that, right? It is a abstraction and there's something in it that you need to protect from the outside world. That's basically what a container is from the real world. So a container can be anything from your soda can or your beer can to the airtight container that you put your food in to store it and save it for the other day or the other week. However, if we think about containers and you see all the graphics when people talk about containers, we most of the time think about these shipping containers. And these shipping containers, of course, you can use to transport your goods from point A to point B. But every one of these containers is there for a reason. For instance, the soda container or the beer container is there specifically to get your liquids in and to preserve the flavors and make sure that the bubbles are in. And the same holds for the airtight container. The airtight container is there to have that protective barrier from the outside world so your food stays good, healthy, and tasteful. For the shipping container, it's pretty much a bit different, but again, you put your freight in there, you put your goods in there to get transported from one side of the world to the other side of the world and make sure that it doesn't damage and it comes there in a good condition. So we can say again, it's a protective barrier to make sure that whatever is there on the outside world cannot interfere or cannot connect with the inside of the container. So naturally, there is a misconception about containers because people see these software concepts like containers and they translate them to things in the real world. But it's not really true because the point is, well, some things are true. For instance, you have to pick the right container. Think about it. If I put my beer in the airtight container, that kind of makes sense. It might work. But if I put my beer like without the can in the shipping container, that doesn't make sense at all, right? So you have to pick the right container for the right purpose. But there is another thing. People have that misconception that if I put something in a container, by default, it is safe, or because of that layer of abstraction, we are safer or something like that. And that is absolutely not true. Say we have a container containing a Java program. And yeah, of course, I put the airtight container in. But if I put Duke in there, he will not survive because it's airtight. However, if we look at this from a perspective from a computer science container, we need to have interaction with that container from the outside world to the inside and the other way around. So instead of having only the protective barrier, it's basically a container with holes in it. We need to connect from your program to, for instance, a UI to a user, but also connect to a database and have that data back in your container. So that means there are holes in there. So it's not the same as the container in real life. And putting something in a container doesn't by default make you safe. And I will help you with that today. But first, this is me. And you see this picture is before COVID. I grew a beard. I have longer hair. and I am dying to get outside again and hopefully get some tent that is not from these lights over here. You see, I'm a developer advocate and engineer for Sneak, and I do a bunch of stuff in the community. I'm a Java champion, already mentioned. Do some stuff for virtual jugs or for jugs. Do something on DevSecOn, which is coming up next week. This is pitching. I know. Anyhow. Let's get into the containers, because let's specify this in Docker containers, because containers is more than just Docker, but Docker is by default basically the de facto standard nowadays. You agree? Well, if you look at how many Docker containers are downloaded on a weekly basis, it is tremendous. It's amazing how many Docker containers are used, and they are just loaded from Docker container and used to create your own container. And that is good. I mean, it's a good resource, but there are some pitfalls, and I'm going to help you with that. And basically, what I'm going to show you is 5 basic tips not to fail your security on creating Docker containers specifically for Java developers. First, of course, I already told you, like with a real-life container, you have to think of what container do you pick for what purpose. Getting your beer into that shipping container doesn't make sense, remember? So choose the right Docker base image, because the base image is what you build your stuff on top of. Because if you look at a Docker file, if you build a Docker file, the first line is something like this: from Ubuntu, or from Debian, or maybe even from Node, or from OpenJDK. What happens is you download that image from Docker Hub, or any other resource, of course, but yeah, let's say Docker Hub, and you use that as your foundation to build your stuff on top of. And that's absolutely fine. But do you have any clue what you're getting into? Do you have any clue what you're pulling into your system? I did a research in 2019, and that's called that report is still on the Sneak website. It's called Shifting Docker Security Left. And what we did was we downloaded the top 10 Docker images from Docker Hub, and we scanned them for vulnerabilities to see if they come with issues. Well, this was the result at that point in time. And of course, that was like somewhere 2019. But the point is, I wasn't aware of this before I did this research. You get me? I mean, you see all these 10 images, and all these 10 images have vulnerabilities. But if you look at these images quite closely, first of all, what I did was I downloaded a Docker container, just the latest. No special tags, no special hashes, just the latest at that point in time. So if you do that again today, the numbers will be different. Absolutely. But what we can see is if you look into these images, that most of the mistakes or most of the security issues come because this image, like the Node image or like the HTTPD image, is based upon another image itself. And that is most of the time a full-blown operating system like Debian. And if you have a full-blown operating system like Debian, it brings a lot of binaries into your system. Then you have to think of, do I actually need them? Do I actually need all of these executables and all of these libraries that come with a full-blown operating system if you're just running a microservice or a small program inside a container? Probably not. And if you look at the Node image for this instance, it says 500 something, and these 500 something problems were not so much to Node, but at that point it was based on Debian Jessie, and the Debian Jessie was already kind of bit outdated, but it was still the latest image of Node, and you inherit it like in a second level. So if we look at vulnerabilities on operating system images, we see that it makes a lot of sense to pick an operating system or to pick a base image that is based upon an operating system that is suitable for your needs. I'm not saying that you always have to go with Fedora or Alpine, because they are very slim, tiny operating system layers. Maybe you do need something more, but we have to take care of that. Like, what do you need to pick? What do you want to pick? And what are the consequences of that? But just because you saw something on Stack Overflow and it says, hey, just from latest image of OpenJDK, that doesn't always make sense. So if we translate this, and you see that, for instance, if I took a full-blown Debian system and translate that or switch that same image out for basically the same image for instance, OpenJDK to one that is based on Ubuntu or to Debian Stretch Slim, it already reduces the amount of risk that I have. Because although we're not sure that these binaries can be hit or can be directly hit, most of the security issues are not so much a direct hit. They are a chain. So somebody gets in, finds something, connects that issue to another issue, to another issue, to another issue, and then it explodes. You get me? So it's not, most of the times it's not a direct attack. It's indirect, just like these problems are. If we translate all of this to, for instance, the stuff from our dear friends of Adopt Open JDK. And spoiler alert, the JVM report is coming out in a few days, maybe next week. And Adopt Open JDK is one of the major JDK builds that is out there, used by a lot of people. And so are the Docker images. And if you see that, the latest image by default is built on top of Ubuntu. But if you want to, you can choose a Debian image. But if you don't need to, maybe it's wiser to choose an Alpine image. And then you say, yeah, all these things that are there, what can possibly go wrong, right? I'm having my Java application. My Java application is steady. What can possibly go wrong? Well, I will show you in a minute because I'm going to talk about this vulnerability. It is an improper input validation vulnerability in a package called ImageMagick. And ImageMagick is part of the Debian distribution. But this is, of course, an old thing. But if your application is connected in some way to something that is there on the operating system, either a program or a library, then things can go sideways because they are connected. And this one is connected, and in such a way, this one was so heavy that they called it ImageTragic, which I think is funny because of the name. So let's get into that problem. I have let's go over here. I have a Docker image, and my Docker image, it's running here on the background. You don't need to see that. I just did a Docker compose up, and it's there. And let me enlarge this one. Let's go into this Docker image and see what is there. So I connected to this Docker image, and if I just see what is there, you see it's a very, very small Node.js application. And why did I do that? Because it's fun to make. Well, no, because this is a Java and JavaScript conference and not just Java. But you see it's a small Node.js application. There's nothing really going on here. And that run is running in this browser. And what it does is quite easy. I can choose a file, I can choose an image, and it will resize that image to an image that is a good size for a Twitter picture, because Twitter resizes it already. So I can't do that before. And what I do, you see, I picked my picture from DevSecCon London, and I reduced it to a perfect image size for Twitter. Nothing more, nothing less. And I'm using ImageMagick in the back to do this. But there is a problem with ImageMagick, and it's not so much my application, but I'm relying on this, well, executable or application that is part of my operating system. If I go back and I do this again, and I will upload another image, but let me show you what that image is. So let me go. Am I in the right one? Yes, I'm in the right one. So what if my image looks like this? Let me enlarge this one and you see what's happening. It's not your typical JPEG image, but this is possible in ImageMagick. I'm just can describe a few things, like similarly like I do that with an SVG image, and I can create a view box. And in that view box, I can relate to a JPEG in another URL. This is perfectly valid. The only problem is, because ImageMagick doesn't do proper validation, I can break out of this by this pipe and say touch RCE1. So basically what I'm trying to do is I'm trying to upload this image, break out of the searching for this JPEG, and try to create a file in my Docker image. Just to be sure, this was the thing, and RCE1 is not available here. You got me, right? You see that. So going back to the thing, getting RCE1.jpg, it's there. I resize, and no image is there because we broke out of it. But it did execute the statement that is there in that application. So if I do an ls-l over here, you see that I created a file in my Docker image, RCE1. And that is because I based my stuff on top of an image that is quite old. If I reduce that to, for instance, an image that is newer, or maybe I don't even need image magic, then I would not have this problem. Moreover, now I forgot what I wanted to say. The point is, make sure that you have the least amount of resources in your base image that you pull in, because it's not only making your image bigger, it also gives you a lot of new attack factors in your Docker application, in your Docker based application. And this is not specifically Java, but it's very keen to. It's something you have to be keen on while you're programming for Java anyway. All right, let's continue. Yes, we had image tragic. That's interesting. So basically what I'm saying is that we only need to use what we only want to use what we need, right? Don't get more stuff in because it will pile up, the image will get bigger. But if you look at for instance, Stack Overflow, you read images about how to start with Docker. Basically what you see is kind of this. Like, I have a project, maybe this is based on a Spring Boot project, and this is my Spring Boot project, and I want to Dockerize this. If you look at a bunch of blog posts, you will see this. And this perfectly works, right? I'm basing my image on top of a Maven 3 OpenJDK 11 image. I copy all the source files that I have. I create a work there that I will put as my base directory. I will Maven package, and I will skip the test, and I will just use the Spring Boot plugin in Maven to start my application. Oh, it must be Spring-boot and not Spring _. But you get me. However, this image for my thing I did was a very small Spring Boot application that was 800 something megabyte. And I know Spring Boot already brings in a lot of stuff, but most of it was because I'm having a lot of stuff in that I don't need. Do I need, in my production image that I want to put on my production server, do I need Maven? Do I need the source code? Do I need the JDK? Like, getting back to old school Java, what do you need? Like, we're building a JDK, or we're building a Java application based on a JDK. There comes an executable out of that. And either if you run on a web servers or within a Docker container, if you're running Pajara or whatever kind of web server, or maybe old-fashioned JBoss, you're just putting in the jar or the var or the ir, the artifact that you build. So you don't need all the crap around that. That's just for building the stuff. But say I want to build in a Docker image, I can just separate the two. I can build an image and compile and do all setups in a Docker container if I want to. But then I want to transfer it to a production image that only has the necessary stuff that I need. Luckily, within Docker, there is this multi-stage build thing. And it looks a little bit like this. So instead of the first 5 lines, I refer to that for the first few lines as an image, and I call it as build. In the second part, as you can see, I refer to that build. So what I'm doing, line by line, I'm getting that Maven image. I'm doing the same thing as I did before, but I'm running Maven package, because then I have the artifact. That's all I need. Then I create a new image, and I base that one on an OpenJDK Alpine Java runtime environment, because that is all I need. And yes, if you want to have more tooling in, then you should be adding that as well. But don't put a full JDK in, because most of the time you don't need that. But pick an image that is appropriate to you. Alpine JRE was perfectly for my thing. So I create a file. I just copy the stuff from the target directory. Basically, I'm only copying my jar, because that's the only one I need. It's a Spring Boot application. It works out of the box. And what I do then, I just call that Spring Boot application by a simple Java -jar, and it runs there. The build image is separated from the production image. That means that only the production image will go into production. First, it was 800, almost 900 megabytes, and now it's about 198 megabytes. So that's already saves me time when uploading the stuff, when putting the stuff over the wire to maybe another pod to spin it up. You got me. Moreover, it also helps me prevent unnecessary binaries in my application. The other point is, if we need to insert secrets in a container, you want to separate that, because that's the build stage. And I made a small application over here where I say I need to connect to a repository, and I'm using command line separators to get a username and a password in. I can perfectly do that in my build image, because that build image will stay behind. Only the production image I will put into my production image, into my production environment. So if I need secrets or other things, I can do that perfectly in that build image, because there is not a trace in the production image that links back to these secrets. If you don't do that, we can look at the history of a Docker file, and we can actually retract these things because they're part of some way the cache and how you build up that image. So using multi-stage builds, only what you need. So in this case, a Java runtime environment is only what I need in production. This already separates the stuff a lot and will get me a lot safer. Next one. The least privileged user. Well, let's get into the least privilege principle. What is it? Basically, what I'm saying with the least privilege principle is we only get access to what we need, nothing more, nothing less. So we only get access to what we need because we need to use it. If you don't need it, you don't have access to that. Think about it. If you go to a hospital and you have some sort of rare disease, you only probably want the nurse and the doctor that is treating you to know that, right? Not the other nurses, other doctors, every patient in the hospital, and maybe even your insurance, because if your insurance knows what kind of things you have, it might increases your fee that you have to pay monthly. Same holds with privileges for users. Because what happens is, if I have a Docker image like this, I have the least amount of resources in it, but by default, a Docker image runs as root. So the point is, I don't want to have this in. I don't need to run my application as root. Because if I can run as root, I might be able to connect with that with an SSH tunnel and do all sorts of other stuff with binaries that might be there or might not be there, or install new stuff and do all sorts of weird things. So let's get to that second part, that production image. That's what we need. For the production image, I just add a few lines. Just do it, like bam, adding a few lines. Like, okay, what did you do? Well, let me light them out for you. These are the lines I did. And remember, this is an Alpine-based image, so it might be different if you're doing this on a Ubuntu-based image or a Debian-based image. But what I'm doing is I am creating a system user. I'm creating a system user with no home directory and no shell access, and I'm adding that in basically the third line of my build image, or of my production image. Then I copy all the stuff, and then I give that new user that I created, I give it ownership of that project folder that I need. It only needs that folder. It doesn't need to go in or out of there. It just needs to go into the project folder, and might be able to create new folders over there because I need to upload things, for instance. So creating a new user that has less privileges is key over here. But then the third line is, I think, the most important one, because just creating a user doesn't make sense. You have to call it as well. And that's what a lot of people forget. Because of the third yellow line, user Brian Vermeer, I'm calling that, and every single thing I do afterwards is run by that specific user. But think about it. If you're using, for instance, an image like OpenJDK, and I know for sure, for instance, the node images by default already have a user that has less privileges than the root, it might be suitable for you to run that, to use that. Only you have to make sure that you call it before you actually execute your program. So calling that user is essential, or else it will still be running as root. But you get it. Now I'm not root. I can do less harm. I can basically not go into certain things I don't need to, only the stuff I need for my application. And that is something that is just as essential as not having all these things in. All right. I told you about the base image, right? I told you already about the base image, and in the meantime, I did on the background, I did a scan just to make it interesting. Let me check over here. It was this one or this one. Yes. What I did over here was, let me scroll all the way up. And what I did was I used our sneak tooling, to do a test on the adopt OpenJDK base image. That was one of the first images I called you. And what it does, it just gets the image from the internet, and we can scan that image and see if there are vulnerabilities there, and what are the vulnerabilities. So for instance, what we see is that this one has 26 issues. And this is the latest one, is based on Ubuntu. If I do, for instance, the Alpine one, it will be less or more, of course. But now you have a good insight if I want to use this image in the first place. I can do this with my image, with my own images as well. So if I do a Docker image ls, I will have, let me see what I have over here. SG1 is one of the images I created today. So I can create images. I'm not sure what's in that image. SG1 or C container test SG1. Let me just do this so you actually see it. And it scans my custom container. And it can scan for the operating system, but also for extra binaries that I add. And what it sees, it looks at the image, and I can also connect the Docker file if I have it, so it can give me remediation advice. But that's super helpful for building your image from the get-go to make sure that it's safe and sound. Well, this is going on. I already did the other one in the background, but there is tooling available, and I'm using my tooling, of course, but there's more tooling. But there's tooling available to know this on forehand. For instance, if you go to Docker Hub, and you do the Docker, you have a Docker Hub Pro account, you already got some of this information from the get-go because Docker implement that already. Sleek trick, that information comes from us. Anyhow, you see that I'm using critical severity vulnerabilities on GC. Well, you got it. And then you have to make sure, like, is this the base image that I actually want? Because it's based on Debian 10. I don't need Python. You get me? So this all you don't need. Get rid of it. All right, but scanning your application is one thing, or scanning your Docker container is one thing. We also have to scan our Java applications because most of the time the application is the entry service. But let's get to the Docker container first. If we ask people, and we did this research in 2019 again in the States of Open Source Security, and we asked people, when do you scan your Docker images for operating system vulnerabilities? Unfortunately, half of the people don't. Well, which is on the bright side, half of the people do, but you get me. It's something that is not one thing that is straight on our mind. And I already showed you that I can pull a Docker image like this, a Docker pull, in this case, latest, and I can just scan it, and I just showed you that we have some kind of result like this. I can do it with my own image, like I showed you, and I can attach the Docker file or the place where the Docker file is, and it gives me already the information in my screen. If I do a Docker monitor, like on the second line, it will take a snapshot of that point in time, and it will bring it to, in this case, RUI, and it scans it over and over again on a daily basis. Because if that thing is in production, there might not be a vulnerability now, but that might occur like tomorrow or the day after. So you want to know, you want to stay on touch of that, you want to repeat that ever again, and you don't want to do that by hand. So Monitor is a solution for that. But then you come to your own application. And if this is your application, think about it. How much of this application is the code you wrote yourself? Think about it. It's probably this. Because, hey, we depend our stuff on frameworks like Spring Boot or Quarkus or whatever you're using. And these frameworks containing, well, libraries, and these libraries containing more libraries underneath and more libraries these depend on. So it's several layers deep. We include stuff from the internet, or basically open source stuff, that we do to make our life easier. We do not want to do yet again another REST endpoint, or we do not want to create yet another CRUD repository. That heavy lifting needs to be done by libraries, because we want to focus on business logic. But think about it. Your code, we probably have some things in place, like code reviews and maybe some automatic QA, maybe pair programming. So we take a lot of pride in that. And no code goes into production before actually, say, 3 or 4 people saw it. But what about all the other stuff that you include? How do you handle these? Did you just blindly include them because Stack Overflow told you so? Or did you include them like a year ago? How do you update them? How do you stay keen on that? Because most of the problems, if you look from a security perspective, are not so much in the top level dependencies, so the purple parts. If you look at Maven Central and NPM, it's most of the time in the indirect dependencies, because, hey, bringing in a Spring Boot parent and just Spring Boot Web or something like that, or MVC, gives you a dozen or even hundreds of packages that are there and are available in your class path. So what can go possibly wrong with my application? Well, yet again, I will show you. I have a Spring Boot application over here, another Spring Boot application, and this application is a very, very simple one. It is a grocery list containing beans for 50 cents, milk for $1.09, and bread for $1.50 and more. This is not really important. This is the domain entity. It's an item, and it contains an ID, a name, and a cost. Super interesting, and some getters and setters. But the interesting part is in this part. This is the repository. And what I can do with my repository, you see that I'm using Spring Data. And with Spring Data, I can extend to CRUD repository. And most of the Java developers know this is super easy because now by naming conventions, like find by name and just say a name will be inserted, I can do a bunch of stuff that I don't need to implement. Spring will handle this for me. Like generically, magically, it is there. I can do custom queries like this, but the point is with Spring Data REST, I just have to implement an interface or Spring Data like that. And with the CRUD repository, I just have to implement an interface. And I already have CRUD functionality. With Spring Data REST, what I'm using here as well, I can add this annotation on top of my application, and my CRUD repository will automatically be transformed into REST endpoints, which is super convenient because now I can do prototyping. My prototype is already done, and people can talk against it. Let me run this one because I run a couple of demos already, and I just hope that this one works. That we don't have any overlap, any port conflicts. And I think it's there. Yeah, it looks like it. Cool. So let's go into the application that I just showed you, and saying localhost 8080. It will bring me to my Hell browser. My Hell browser is just there to show you what kind of REST endpoints I can call. Like I can call item/1, and item/1 will give me the beans in my grocery list. Of course, item/2 will give me, you guessed it, the milk for $1.09. What I can do as well, I can do a search and a find by name, which was my CRUD functionality, and give it a name as a parameter, beer. So my CRUD and my CRUD functionality is now a REST endpoint. Oh, don't put a %20 behind it. Just do it like this. And you see, marvelous, it works. So this is all cool and stuff, but we're depending on a framework. And I'm not depending on a very stable version of this framework. Trust me, we wrote it. The point is, there is an issue with this framework, with specifically Spring Data REST, specifically this version, and hopefully you're not on this version again, or you're not on this version. And I will show you what the problem is. So say I'm going into this application, and let me just enlarge it a bit. Going to the exploit folder, and I prepared something for you. So what I can do is I can call some endpoints with a curl request and curl patch request, and I can give it a certain body. Because if I do a curl patch request, I'm allowed to supply a JSON body. But what if the JSON is this? And I will enlarge, I will enlarge it for you so you can actually see what's going on. And what you see is in this JSON body, I am doing a weird stuff. I'm utilizing SPEL, the Spring Expression Language. And with that Spring Expression Language, I am allowed to interfere with objects that are there in my memory. And what I do over here, you see a little bit, it's get runtime. And what I do with that runtime, I execute an arbitrary command. So if I'm able to get the runtime and execute an arbitrary command, I can do vicious stuff in there. Let's try this. So let's get into the PassWD folder file, because why not? So what I'm doing here is, let me just get this, clear my screen and show it again. I'm doing a curl patch request, and I'm saying, hey, it's application JSON patch. Fair enough. And I'm giving it this body. And instead of saying command, I now go to the /etc folder in my root and go to the PassWD file. However, I call this on this endpoint, And this item/1 endpoint was just there to get my first item out of my grocery list, which I assumed was just a get endpoint. But by doing this, you see that I now have the containment of my pass.wd file. And if I have the containment of my pass.wd file, that's not really important, but it's the start of a journey of exploring what can be done as more. I can also get the environment variables, but if I can get the environment variables, I'm also able to create files, delete files, create a file and put some scripting in it, create a file, or actually execute anything that is there in my Docker container. And there you have your entry point, because I'm using a library and I wasn't aware of it, that this library had this exploit, because I didn't test around it, because I didn't know. And again, we can get rid of this by doing something either in your terminal or in your IDE, whichever IDE you prefer. There are plugins for there to do a test also on your application. So your application service is just as important as your container service. Of course, we can go further and further and go into Kubernetes problems and that kind of stuff. But this is quite connected to each other, because in that container, you already brought a bunch of stuff that you didn't need. And now I have an attack service. And as you can see, we can already show you what kind of problems there are. It's not really important, but we can also say like, hey, you see, I'm using 155 build snapshot. Don't use until build snapshot. 1.5.17 release will fix all these things. But you get me, if you're on the wrong version and you didn't upgrade for a while, you might be in trouble. All right, let's get back to the thing. So the point is that we need to test both our containers over and over and over again during development, but also when it's in production already. But the same holds for our application. And if we're aware of these things, and we can automate all these things. If I can do that with a command line tool, you can do that, and you can automate it in your CI pipeline. And again, not saying that you have to use my tool. I'm just using it as an example. Last thing we need to do is we need to build to rebuild. And that's a weird one. I mean, build to rebuild, what do you mean by that? Well, for instance, this is a Docker container we have, right? The Docker container containing your Java applications. And probably it's not just one container. You might have scaled it up, and you might have a cluster and multiple pods with this Java application like this. Like we have 3 or maybe 300 applications. Say you have everything in place, like logging is in place and you can actively monitor, and then you see in the third pod there's somebody actively doing something weird, or there's something weird going on. What is the first thing you want to do? The first thing you want to do is that specific pod. You want to just blow it up. You want to make sure that it's not there. And then you want to spin up a new one, preferably with a newer version of either the container or your Java application, or both. But that means that you have to start with the architecture already. If you build a Java application, you have to make sure that you just can blow it up, and that you're not like missing transactions, missing data, that your customer data is now gone, for instance. That is not what you want. So things like this, like databases, and in one of my demos, I do things with an in-memory database, but that's because of a demo. But databases, things in memory, but also log files, don't put that inside the container. For a monolith, that might be fine, because you're not blowing things up. You might just do it granularly. But you want to easily replace one pod with another one. You need to be aware that these kind of things need to live outside of your container. And that's, again, if you come back to the first image I showed you, we need to have connection with the outside world, and the outside world has to have connection with our application. But you need to build it in such a way. So don't do databases inside your container. Don't do caching inside your container unless you have an in-memory data grid that has automatic healing. Things like Hazelcast can be used for that. I have no stock options for them, but you get what I'm saying. Use your stuff wisely. And did you know that 44% of Docker image vulnerabilities can be fixed with a newer base image? That means that although my application doesn't have any specific vulnerabilities, by just switching out to a newer base image, we can already remediate a bunch of stuff that we already have. So deploying this Even if your application didn't do anything, didn't change, it is wise to deploy or to rebuild your application with a newer base image every now and then to make sure that you're up to date. We ask people like, how do you find out about vulnerabilities in your deployed containers? And a lot of people, unfortunately, don't. But also, did you know that 20% of the Docker vulnerabilities can be fixed by just rebuilding the same Docker file? Using the same Docker file, rebuilding it. And why is that? Because we do a lot of this. Ubuntu latest. And you already get me, right? What is latest now is not the latest tomorrow. So by, again, rebuilding your, and then I'm just inserting, in this case, Python or whatever binary I have. Don't just do that. Or, well, you can do that, but then you have to rebuild this often. Even though your application binary didn't change, this can be a tremendous difference in the amount of vulnerability factors you have. If you do rebuild, because the latest now can be different from the latest tomorrow and the latest a week after that, just make sure that if you build it, that you use the -- no cache flag, just to be aware that you are absolutely sure there's no cache hit. You get me? Normally that wouldn't be an issue, but hey, do we trust machines? I'm not trusting machines that much. And then people say like, yeah, but you can use a specific tag for a Docker image that you're basing your stuff upon. That's absolutely true. But then you have to still manually be aware of that there's newer versions out. So whatever approach you choose, it means that we have to maintain the Docker image and the Docker file in the same way as we need to maintain our application, the same way as we need to maintain our technical debt, the same way as we need to be aware of security issues in our application, we need to be aware of security issues in our Docker containers. So I gave you a bunch of stuff already that can help you building safer Docker containers, and are just small things, but small things matter. Let me recap that for you. First of all, we need to choose the right base image. Picking your base image is not only sizing down your container or your image that you finally built, but also prevent stuff that you don't need. And if it's not in your container, it cannot harm you. Secondly, use only what you need. For instance, you don't need to JDK, you don't need Maven, and you probably don't need your source code. Well, get me this. Just thinking out loud. If I have Maven, the JDK, and my source code in a container, and that container is alive, and for some reason I can't get in, I can change the source code, I can recompile, I can execute, and while that container is still online, I can create a bug in it, or I could create an exploit in it. That's fun. If it's already built, of course I can decompile it, but there's no JDK there to rebuild it. There's no Maven there. So don't do that. Make it smaller, only what you need. And again, you can prevent getting sequenced in. Third one, don't ever run as root. Don't do that. And a lot of other systems that run with different or do containers already have that figured out. For Docker, you by default run as root, and don't do that. It's easy just to create a new user. It's just you have to be keen on that. Then scan your applications and images on a regular basis. Not only when you're going to production, not only when you're developing, but preferably both, and also when you are in production. When you're in production, just make a snapshot of it and monitor it. I showed you the Sneak Monitor, the tools already that you can use for that. But basically what we do is you create a snapshot of that point in time, because at that point it's static, and you can just scan it over again and just connect to the sources that give you information if there are vulnerabilities known. And then build to rebuild. You want to absolutely be sure that at any moment in time, you can demolish one of your pods and spin up a new one. That will make you vibrant. You can connect, it will make you scalable, but it also, if something happens, you can shut it down and you can prevent worse. You can prevent, like if you see that someone is in and you can demolish that container, you can just get rid of it. That hacker needs to start over again, or you just prevent more harm to your system. If you can prevent that an attacker can do more harm, you actually save probably the data of your customers. These are just 5. We have more. And we did it in a 10 best practice container Java for Java application cheat sheet, which is available on our blog post. but I'm at the 45-minute mark, I see. So if there are any questions, first of all, I want to thank you for your attention. I hope you find it interesting. I hope you find it useful, at least one of these tips. Then I'm already a happy camper. If you have any questions, please feel free to ask them now or ping me later on Twitter if you come to a question like, say, tonight, tomorrow, when you're showering, when you're in the toilet. It's all fine by me. Ping me on Twitter. That would be the best way. Or ask them now. Thank you for your attention and enjoy JNation.
Thank you, Brian. Awesome talk as always. There's one thing that happens to me on all sneak talks, which is, man, I always end up the sessions thinking I need to get back to my code. And I think the rest of the guys are feeling the same way because we don't have questions. So I guess everyone is busy now trying to get to their Docker images and fixing potential issues. I really like these kinds of talks where you just do not only talk about problems, but actual solutions for problems that we all have. So kudos for that. And since we still have 4 minutes, I'm going to give you time to do the shameless plug about DevSecCon 24.
well, in a week, next week we have DevSecCon 24, which is basically a conference that we I wouldn't say that we own, but that we do to promote application security, and that's not specifically for Java or JavaScript or for architects or for. It's a crossover. So if you care about security in general, like it can be from threat modeling to application security to Kubernetes misconfiguration, these kind of things that are all needs to be part of your tool set as a developer, I believe. Then hop on. I mean, go to just Google DevSecCon 24 and you will get there. Go to the Snyk site and you probably find lots of links over there. It's free. Just hop on. Even if you have just one talk or two talks, just hop on and do that. And I hope it's useful for you. That's the only thing I hope. So that's it.
There we go. Thanks a lot once again, Brian. Really hope to have you on board next year to actually experience what JNation is all about and not just the virtual part. So hopefully we'll have that opportunity next year.
I hope so. Really I hope so too. I will do my best to create a new topic, a new talk, and so that the program committee will pick me. That is what I can do, and I hope that the gods and the governments are with us, that we can open up again next year. I am confident that we can. So I will make you this promise. I will do my utmost best to be in Portugal next year at JNation.
Yeah, thanks a lot, Brian. So guys, if you want to contact Brian, you have his Twitter on the website. So I'm giving the guys your Twitter. I hope you don't mind.
Sure.
And
more followers, the better.
Yeah, the more followers, the better. Yeah, just influencer style. I see your reaction over there.
No. I'm not making TikTok movies and that kind of stuff. I'm just doing.
Man, that's disappointing. That's disappointing, man. So that's a wrap. Thank you very much, Brian, for the awesome talk. So in 10 minutes, we'll have a new talk on Almadina Room. And it will be a hidden secrets about instrumenting JVMs for open telemetry by Ricardo Ferreira. So join us in about 10 minutes and I hope to see you all back here. Thank you very, very much, everyone. Thank you once again, Brian.
Bye-bye.